Hi, this is Nathan Melcher for demonstration 2, calculus 3A. So for the first question here, it asks us demonstrate. It says to correct one problem from the second exam. So I did question 5, and question 5 was 3 parts, and you got to choose. So I did B. B states that there is a 15-foot ladder. Excuse me. There's sorry, let me pull up the exact one here. 15 feet ladder resting against a vertical wall. This vertical wall right here. It slides away. The bottom slides away at a rate of 5 feet per second, which I have here, 5 feet per second. And currently the bottom of the ladder, or it asks how fast will the top of the ladder be sliding away when the bottom is 9 feet away. So I drew a little triangle here just to for frame of reference. Here's the ladder, here's the distance away, and here's the wall here. So what you first have here is basically just to solve for y squared, which is what this is missing over here. You end up getting y squared is equal to 144, or y is equal to 12. So then you bring it down to this equation here, and to calculate the rate or the speed of the ladder, the top of the ladder when it's falling, you can use excuse me, 2x x prime plus 2y y prime equal to 2 or equal to 0. Divide both sides by 2 just to cancel these 2's out here. So then you have x times x prime plus y of y times y prime is equal to 0. You can subtract the x primes from both sides because we are looking for the y prime here, which is the rate at the top when it's falling. So then to find y prime, you need negative x times x prime over y. We have all these values here. So the x is going to be the distance from the wall, which is this 9 down here. So you've got 9. Then this 5 here is what you get is how far the bottom is sliding. So the bottom here is 5 feet per second. So then that goes here at this x prime. And then the 12 is what we got this y here. Is the y. So then when you calculate all those out, excuse me, you get 3.75 feet per second. You have to make sure it's negative because you're sliding away from the wall. So it's in a backwards direction. So you got to make sure it's negative. So negative 3.75 feet per second. Then for question 2 of the demonstration, it asks to find the particle where it's speeding up, moving forward, or speeding up, speeding down, moving forward, moving backward. And the equation for that particle is negative t cubed plus 6t squared plus 135t, assuming that t is greater than 0, which is important. That'll come in later. So the first step is to find the derivative of this equation here. And so you use the power rule. You take the power minus by 1, move it down the front. You end up getting negative 3t squared plus 12t is equal to 135 is equal to 0. You set that, or you set it equal to 0, and then you can find your critical points, which end up being 9 and negative 5. But the negative 5 gets thrown out because it's not greater than 0, which is that really important condition that they gave us up top there. So then all we're worried about now is negative 9. So then when you put it on the chart, you're gonna chart negative 5 here, and 0 and 9. So then what you do is you pick a point before, in between, and after. So what I picked is I picked negative 6, 1, and 10. So I end up getting 81. Excuse me, that's not right. That should be negative 45. We have negative 45 here, which it's negative means it's in the negative direction, but we really don't care about anything on this side of the 0. We don't care about it. So that can we can throw that out. So now we're dealing with the 1 here. And this 1, you plug in 1 for the equation, you end up getting positive. So this 1 here is positive direction. The 9 ends up, the 10 is a negative. So that's moving in a negative direction. So we can tell that it's moving forward from 0 to 9 based off this 1 here. So the 0 to 9 is moving forward from 0 to 9, excluding 0 and 9, the parentheses, not brackets. And important to note that we're still relying on that condition of t is greater than 0. So we don't have to write down the other points. Then for backward, we have 9 to infinity because we did find that it was negative after 9. So we'd assume that it's moving backwards from 9 to infinity. Once again, assuming t is greater than 0 because we don't have to worry about anything on the left-hand side. Then for speeding up and speeding down, what you have to do is you come down here and you find the second derivative of the very original equation, which ends up being negative 6t plus 12. And then you solve for t and you end up getting t is equal to 2. And so 2 becomes another critical point, but then you have to come back up here to this number line and line t back, line these number lines up here. So you have these two number lines, 0 is lined up, 9 is lined up. Once again, we don't care about anything to the left of 0, so we can cross all that out. Then what you do down here is you look and see from 2 whether or not each side is equal to each other. So we did find that 1 is speeding up, and so is on the other side of 2. So that's positive. So it's speeding up at these points, but it's not speeding up at 2. So you have to exclude 2. So that's why it's parentheses with the union. And once again, you denote we're still using the parameter of t is greater than 0. And then slowing down is anything after 9, since the symbols are different at 9. Or excuse me, on this number line, symbols are different on either side of the 9. This one's positive, this one's negative. That means that everything onward is slowing down. So that's why you have 9 to infinity. And once again, denoting that t is greater than 0. And that's all for demonstration 2.